Welcome, my dear learners. We are still on circle theorem and we are looking at the tangent to a circle. Tangent to a circle. Now, a tangent is a line that touches a circle at one point only. So, anytime you have a straight line like y and q, and this line yq is touching a circle at one point only, that line yq is said to be what? A tangent line. So, we can see that YQ is a line and is touching the circle at point A. It is touching the circle at only point A. So we can say that YQ is what? A tangent line. Now when we come back to this one too, now VT can also be called a tangent line because it is touching the circle at only one point. That is what? Point B. Now, anytime a radius of a circle meets a tangent line, an angle of 90 degrees is formed. So this is my radius, this is my radius. Now, the radius becomes a perpendicular line to the tangent line. And anytime a perpendicular line meets a normal line, an angle of 90 degrees is formed. So you can see that our VT is the tangent line and then our radius OP is the perpendicular line, and this perpendicular line is meeting the line VT. Therefore, an angle of 90 degrees is formed. Now when we look at YQ, we can say that the radius R is the perpendicular line and it is meeting YQ, which is the tangent line, at point A. Therefore, the angle created here is 90 degrees. Now, the point at which the tangent line meets the circle is what we call the point of tangency. So we are going to base on these few properties of tangent to a circle together with the circle theorem to solve questions on circle and then tangents. So let's take the first example. So we have the first example. We have, if O is the center of the circle, find X, Y, and R. So we are going to find the value of X, Y, and then R. Now, we know that we are saying O is the center, therefore OC becomes what? A radius. And since OC is the radius and it is meeting a tangent line at C, we can say that the angle created here is 90 degrees. So we can say since OC is perpendicular to CP, that is the tangent line, angle X is equal to 90 degrees. Very simple. Now we are done with X, which is 90 degrees. Now we have to find angle Y. Now that we know angle X and then 30, and we know that OCP is a triangle, so we can use the sum of interior angle of a triangle. So we know that OCP is a triangle and the sum is equal to what? 180 degrees. Therefore, Y plus X plus 30 degrees is equal to 180 degrees. And we know the angle for S, it is 90 degrees. So we know that Y plus 90 degrees plus 30 is equal to 180 degrees. So you can see that Y plus 90 plus 30, we have 120 is equal to 180 degrees. Y is equal to 180 minus 120. Therefore, our Y is equal to what? 60 degrees. Very simple. Now we are to find r. Now r is not an angle, it is the length of what OC, that is what the radius. Now we know that angle x is at 90 degrees, and if that is the case, then we can apply what? The Pythagoras theorem. So since angle x is 90 degrees, we can apply the Pythagoras theorem. I hope you remember and you know what the Pythagoras theorem says. Now, the Pythagoras theorem is saying that the square of OC plus the square of OP is equal to the square of OP, which is what the hypotenuse. So the square of the hypotenuse is equal to the square of the two sides. So it means that we are going to get OP squared, this one, is equal to OC squared plus CP squared. Now we know that OP is equal to OP squared. Now where is OP? OP is 18. So we have 18 squared is equal to OC is R squared plus CP, which is what? 12 squared. So we are going to get 18 squared minus 12 squared is equal to R squared. Now 18 squared will give you 324, and then 12 squared will give you 144 is equal to R squared. Now 324 minus 144 should give you 180 is equal to R squared. So what do? We take the square root on both sides. So you can say that R is equal to root of 180. Our R is equal to 6 root of 5, or our R is equal to 13.4 centimeters. So that is the value for R. Now we are done. Now the next one that we are going to look at is called a tangent kite. A tangent kite. So this is the tangent kite. Now a circle and two tangent lines can be joined together to form what we call a tangent kite. Okay, now this is one tangent line, and QT is also a tangent line. We have a circle. Now when we join these two tangent lines, we are getting what we call a tangent kite. You can observe that POQT resemble what we call a kite. Now let's look at some few properties of this tangent kite. Now from here we can see that the length of QT is equal to the length of what? PT. So we can say that the length of PT is equal to the length of what? QT. So you can also observe that the length of OQ is equal to the length of what? OP, and that is what? The radius. Now we have also learned that when a radius meets a tangent line, an angle of 90 degrees is formed. So you can see that angle OQT is equal to angle OPT, and these angles are equal to what? 90 degrees. Now we are going to apply these properties of the tangent kite together with the circle theorem to solve questions in our next lesson. Thanks for watching.